So in this video we're gonna look at collections. Collections in Kotlin is same as arrays in other programming languages. So using collections, why do we use collections? Collection types, sometimes called data structures, let you store multiple values, typically of the same data type, in an organized way. A collection might be an ordered list, a group of unique values, or a mapping of values of one data type to another. Okay, with collections we can store arbitrary amount of data. So far we've been using strings and integers. We've been storing these data types in variables, but now we're gonna store groups of strings, groups of integers, basically groups of data. The amount of data we can store can be varied, so that's why that's what arbitrary means. Okay, array. So there are a lot of different collections. Some are mutable, some are immutable, but first let's look at the basics of the basic. It's called arrays. So we'll look at immutable list and immutable list. So the difference between arrays and lists is that arrays are fixed. We'll get into that. First let's check out the arrays. So another thing is arrays are based on zero indexes. Every items in an array is called either element or an item. So the first item is as we say it has a zero index. It has an index of 0, and the second one has 1, like this. So if we have these integers 8, 6, 7, 5 and so on, if you wanted to access, we use indexes. If you use any other programming languages, you will be familiar with zero-based indexes. So if you wanted to access let's say any values in this array, we use the index of the corresponding array. So let's look at how to create a array. So we use array of this function. So let's create a array of strings. Mars So the first thing you notice is that all the elements are comma separated, and we can also tell what data types these elements are by passing the generics to this function, like this. So if we pass in string, every element is a type of string. Okay. If we wanted to access the elements, like I said, we use the indexes. So the Mars has a 0 index and Earth has 1. So with this we can access the value. I'm gonna just print it. Let's see. Okay, it's taking some time. As you can see, the when I access the array with the index, I got the value. Okay, so let's look at weird behavior of this array. So we have what's the highest index of this array? Well, it's 0, 1, 2. So the 2 is the highest index of this array. What if we try to access 3? What happens then? So let's say planets and 3. Okay, so we get out of bounds error. So this is a common type of error that will crash your apps. That we need to watch out for this. So essentially, we cannot access index that's not like we can access an index that's not, I don't know, like higher than the size of the array or something. So we're essentially we're not gonna use the arrays in our Kotlin projects. We use lists and basically lists and other data structures. So when we add a new element, it creates a new array. It copies the old arrays and adds a new element. We can also insert an element at specific indexes. I don't know if we can do this with arrays, but with lists we can do it. So let's try doing that with arrays. So looks like arrays don't have a method for adding items. So if we add a list, we could use add method. What about inserting elements at specific looks like we can insert element at specific indexes. What happened? Okay, we have 0, 1, 2, 3 or 0, 1, 2. Okay, I replaced the element on index 2 with Jupiter. It was previously Venus. Now it's Jupiter. The Venus element didn't go to the index 3. The size is maintained, and Venus, we replaced Venus, and Venus is nowhere to be found. So for now we know array, but like I said, we're not gonna use arrays in Kotlin. We will use list. Just like how we created a list array with array of, we can create a list with list of. With list we have a couple of more methods. We can add elements. We can also add elements with specific um, indexes, remove elements, and check if certain elements are inside of the list. Let's try adding elements. Oh, my bad. Oh, if we wanted to add elements, we need I think mutable list. I'm gonna try to check if we can add to the list, if it's possible or not. Okay, so we cannot add element to the list of method. So what's the difference between a list of and a mutable list of? A list of method returns the read-only values. With mutable lists, you can add, remove elements. So it's both readable and writable. Let's see what they are doing here. They create a list with list of, and then they check the size of the list using the size, and they try to access index using the square brackets. Also we can use get to access the element. We can check with index of, we can check the index. Okay, so that's the thing. They used a mutable list to add element. Okay. Now let's try to access the values. We can use the square brackets and index to access the values. Let's quickly print them. So we get earth is at index 1. So this is one way. What's another way? The another way is using get. So we get Earth, Venus. Venus is at index 2. If we pass in the element to the index of, we can if we pass in the element to the index of, it returns the index where that element is on the list. Mars as index of 0. If we pass Earth, we would get 1, and so on. We can check what's this? We can check if an element exists using the contains. I believe this returns a boolean. False, we get false. If we pass in element that's not inside of the list, we get false. Also, if we try to access um, element that's not inside of the list, we get out of bound error. So these are like read-only methods, so we can access the values using these square brackets and get. We can check if something exists using contains. So this is what they use. I use mutable list. So if you wanted to add elements, you need a mutable list. So I'm gonna change it back. So the thing is, there are common methods for both lists and mutable lists. So mutable lists also has get and contains methods. So that's not something that's specific to list. Let's try adding and removing elements. We add element using add method. This is a for loop. If you have used any other programming languages, you would be familiar with a for loop. You would probably the for loops are probably like have a expression inside of the parenthesis. It would have an initial value and a expression to check a certain condition and incremental value, and then we'll have a loop body. This is another type of for loop. If you use JavaScript, you know what, let me just show you. This is Kotlin, but so if you use JavaScript, this is how the for loop will look like. I don't know why I'm showing you the syntax for JavaScript, but the syntax for for loop in Kotlin is different, right? We use item in planet. So essentially, have we talked about for loops? I don't know. For planets, so we have a planet. This planet has size of 3, right? So the for loop runs 3 loops 3 times. So at every loop it passes the items. the items of the array, or you could call it list or whatever. So for the loop 1, it passes the 0 index at index 0. At second loop it passes 1, and so on. Using this, we can print the elements. Okay, so we had 3 elements, right? Mars, Earth, Venus, and I added Jupiter. Let's copy this one more time. We're gonna remove let's say Earth. So now we have Mars, Venus, Jupiter. We can use either remove or remove at. This gives you a suggestion indicating that we need to pass in index, which is an integer. So essentially you just tell what value at index you want to remove. So far we have 3 from 0 to 3 index. So we added a Jupiter, that becomes the index 3. So if we remove that, we get Mars, Earth, Venus. We added Jupiter and removed it. Either you could use you could pass in the value of the element, or just use index. Last time we looked at how we could use the contain. So it checks contents, checks the existence of a element. So another way to check the existence of a element is using in method. So Mars in planets. Let's copy that. This syntax is similar to contains. Essentially they check if whether element exists inside of array. Okay, so now we're gonna look at sets. Okay, so this is confusing as hell. So essentially a set does not have a specific order and does not allow duplicate values. So what does it mean by specific order? When we looked at a list, it started with 0, 1, 2, 3, so on. So it had a natural order. But sets don't have that. We can't access a set with, I believe, indexes. Also, when you add an element to a set, let's say Earth, and you try adding Earth again to that same set, you don't get to have a duplicate element. So you only sets make sure that every element in the array is unique. They go on and talk about ASCII codes and how they manage to make every element in the list in the sets unique. That's pretty confusing, so I'm not gonna talk about that. We just need to know that elements in the sets are unique. That's pretty much it. So let's try creating a set. We're gonna use the same example. Let's create a mutable set of. We're gonna use the same thing, planets, Mars, okay. Let's try accessing the like using indexes. We get an error. Let's see what it we get. None of the following candidates in the application of because of a receiver type a mismatch. Match group get name. So when we call this, when we use this expression, it tries to call get method. Looks like sets don't have get method. Okay, we're gonna leave it like that. We also established that these use as codes or array indexes. If you read their documentation, they say they use as codes as a way to access the values. We can try adding more elements using add. We can probably use remove add. Let's try this as well. Planets, remove. Let's try adding two. Okay, so we can only add one element at a time, it seems. Okay, planets, add. Damn it. What is this expecting? Okay. There is no print statements. Let's quickly create a loop. So we added Jupiter and Mercury using add. We removed Mercury, so we get Mars, Earth, Venus, Jupiter. So the remove method works. You can trust me, remove add method also works. We can check the size of the this set using size method. Planet size 3. We can check if something exists. Let's say Mars planets contains Mars. Okay. It's almost as if human language does the planets contain Mars. It's as if like we're saying that. Okay, so we most of the methods we looked at for lists also work for the set. So what methods are they? We can add, we can remove, we can also remove add, indexes, get. These don't work. We can check contains, probably also works. Now we're gonna look at map. Map stores key value pairs. So you have a key Jupiter and the value 78. Okay, let's try creating the map. Let's create. We're gonna use the same thing as we're doing. We can use mutable set of and pass in key value pairs. How are we gonna do that? Okay, let's pass in Mars. So how are we gonna pass value? Okay, we use 2. Mars 2. Let's say in this Earth 2 1 Jupiter 2 4. So this is a key and this is a value. This is key and this is a value. This essentially these are a array of key value pairs. We have one key and one value. What if I wanted to have more than them? Okay, I think that's wrong. So we have looked at classes and objects. So objects are quite useful. Objects are singleton objects. Okay, we're gonna create a singleton object real quick. Probably let's call it something like number something. So why are we getting this? Okay, we need to probably have So now we can pass this. So far we have looked at like classes and objects, and I don't know, like we can essentially we can use all those types. We can put an instance of a class inside of this, but keys are unique. We probably use strings for keys most of the time, I believe. So the value can be anything. It can be single value, it can be an object, it can be an instance of a class, I don't know, anything really. How do we get the values? Mars. No get method. Okay, I'll be back. Okay, my bad, I used set instead of map. Let's try using the index. Obviously we cannot use the index for this, so we get an error, but we can use get. We're not using print statement, so if we use get method, we should get the value for the key we passed. Let's try the so we can add new key value pairs using this syntax. We pass in the key and the value, so that gets added. We don't use the add method, so this is like probably add method. We have add remove. What about using remove? Let's try removing it. Print remove, and then try accessing it. Planets get Pluto. Okay, so if the key value pairs does not exist in the map list, we get a null, so we don't get an out of bounds error. So we checked add, remove, add. How does remove add work? We don't have indexes for this. So that's the ordered list. If we use the indexes, we're gonna call it ordered list. So this is not an ordered list. So probably we cannot use a remove at. Contains, we can probably use contains. In probably works as well. Size will probably work. So essentially you got to remember a couple of methods. So you have add method, remove at, contains, in, using square brackets to access a element, and the get method, and size, and so on. Okay, so this is pretty much it for this documentation. I'll see you in the next video.